Hello, everyone, and welcome back. We're going to continue our discussion on the list. We're going to talk about looping with lists, which we have also seen with the strings. So we're going to see how that works on lists. And we are also going to talk about the property of list mutability, which is a new property that we have not yet seen. So let us go ahead and get started. So first, we're going to talk about for loops with the lists. And so the way that the for loops work is very similar to how it works in the strings. So instead of the for loop taking on, so the for loop variable taking on the value of each of the items in the string, the for loop variable will take on the value of each of the items in the list. So for loops can be used with the lists, and the loop variable is assigned to each element in the list in turn. So it will look like for variable in list. And then you'll have your loop body. So continuing on here, we have some cities. We have a list of cities right here, and we can say for city in cities, we can print visit sunny, and then this will substitute the name of the city in the sunshine state, which of course is Florida. So if we have this list here, what will happen is our loop variable city will take on the value of the first item in the list, so Miami, so it substitutes it in and prints out Miami in the sentence. Then we move back to the top and our pointer moves over to Ocala. So just like the pointer moves automatically when we're looping over the string, so too it will move automatically over to the next item as we're cycling over the list. So it will point to Ocala the next time through, and then it will in turn point to each of the items so that we then print out the name of each of the cities as we cycle over the list. Let's talk about computing the average score. So similar to the program we previewed at the beginning of our lecture in this series, we could write a function that computes the average of some test scores. The function should output a float. So here's some starter code for you, average score with lists, and this should take in some scores. I'm giving you some hints here. Here's our signature. It's going to be a list of ints or floats, and it should give out a float. And the precondition is that the length of the score should be greater than 0. It will calculate the average of the scores in the list. So here are some test scores, and suppose you want to print out the average of these, then it should average these all together and print out 92.94. Your job is to figure out how to do this. So if you'd like to pause this video and work on that, you're welcome to do that. Otherwise, we'll reconvene in a moment. All right, well, I hope you had time to have a look at that. Here is a sample solution for you. So what we've done here is much what we proposed when we were first previewing this. We'll set up our function. Here we're starting off with a variable score t, which is going to be an accumulator, and we're initializing this at 0.0. Now we're going to loop over the scores. So we'll do for score in scores like so. The score total will be summing up the score that we're currently pointing to. So we will have a running sum in the score total. Then the score average will be equal to what we would intuitively know for our average formula, the total score over the number of tests that we've had. We can do this with score t, which is in the for loop just summed up all of our scores for us. And the length of the scores will report back how many scores that we have, because in our list, the length of this list will be the number of scores we have. Then we will return the score average. Here's some for loops and lists. You could write a function that determines which city in a list has the longest name, or declare that at least a two-way tie has occurred. The function should return either the name of the longest city or the word tie. Here's some test lists that have been supplied for you: Orlando and Tampa in cities 1, and Tampa, Orlando, Orleans for another test. So you can go ahead and work on this, or we can move forward and have a look at a sample solution for this. We'll see you in a moment. All right, so here's a program that will get the longest cities. The signature is list of string to strings. It will determine which city has the longest name or declare a tie between the two. So the first thing we need to do is we need to initialize the counter to 0 so that we have not had any winner yet. Now we're going to cycle over the cities. So here we are going to do for city in cities. If the length of the city is greater than the longest, so obviously the first time we go through with the length being 0, any city with any characters in it at all, of course, is going to win. So we would then store the longest city and we need to have the longest be equal to the length of the city, right? Because we need to update the longest one we've seen so far. And then long city will update the name of that longest city. It will update it to the corresponding city that we're pointing to. Now we have this else if statement. The length of the city is equal. Remember, we had a special case if there's a tie. This is to deal with that. The long city would switch to tie because there's no longer a clear-cut winner, but we don't need to update the longest because they're the same. It's still the longest one. The length is the same. And then after we cycle over all of our cities, we can return the long city. So here is our list of cities. So let's try doing with the cities one, and let's see what will happen. So the first city that we go to is, all right, so let's do it from the top. So we read in the function, and Python learns how to get longest. And then it doesn't actually execute until we have a function call. We have 2 cities out in main. These are global variables. And now we have print functions, and inside of those with we have the function calls to get longest right here, calling cities 1, and here getting cities 2. So let's first consider the function call for with cities 1. So we send up cities 1, and that becomes the list called cities. So the longest is equal to 0, and so for city and city, so our imaginary pointer is sitting on Orlando. If the length of the city, how long is Orlando? Orlando, 7. So 7 is greater than longest. Well, it's 0. Yeah, definitely longer. The longest will update to the length of the city, which is 7, and long city equals city. So we now assign this variable to Orlando. Next, and so the elif branch doesn't apply, and we go back to the top. Now we have Tampa. So the imaginary pointer is pointing at Tampa. If the length of the city, so what's the length of Tampa? TAM 5, greater than longest? No. Longest, so that's false. So now is the length of the city equal to longest? It is not, it's shorter. So none of those apply. So we have run out of things in the list. So we exit out of the loop, and the next thing we encounter is a return long city. So we will now return the long city, which is Orlando, the winner. Next, we can try this one right here with the get longest of cities 2, which gives us this this list right here. So we'll go through with Tampa, which is 5. So this will become the longest city. Longest will be updated to 5, the length of Tampa, and long city will be set to Tampa. Next, we go back to the top of the loop, because remember, you can only execute one branch of an if block. Next, we go to the top, and we have Orlando. That one has a length of 7. If length of the city is greater than longest, yes, it is. 7 is greater than 5. The longest will update to the length of city. So the length of Orlando is 7. So longest now gets updated to 7, and long city gets updated to Orlando. elif doesn't apply and can't execute anyways. So back to the top. And now if our pointer is on Orleans, if the length of the city is greater than longest. No, it's not. It's equal. elif the length of the city equals longest. Yes, it does. They are both 7. So the long city will switch to tie. And we do not need to store the length of the city, as we talked about before. And that's the end of the list. We get to return. So we'll return the long city, which has been set to tie. And that is how we get the output of tie. We can use range and for loops. So range can be used to automatically count up to, but not including a specific value. So you can do for variable in range, and you can supply an integer and then the body. So you can do for I in range 3, print I. So we've done that before. And so if we do my list equals list of ship, notice that this is a coercion here. So this actually is going to be the list of 4 characters. So for I in range length of my list, we can print I, and then we can see that this will print out 0, 1, 2, and 3. You can also use while loops with lists. While loops can be used with lists much as they're used with strings. An explicit variable incremented by a counter can be used to loop over the list. So you can have a variable equals 0 for the initialization, and then we do while variable in the length of the list, the loop body, and then we would increment the variable by 1. So again, you have your initialization, your while loop, and your loop body, and the variable incrementing, much the same syntax that we had for processing strings. We also can talk about the list mutability. Now, lists are able to be mutated, meaning that we can cause a piece of it to be changed in its value. Assignment versus mutation. The contents of a list can be mutated after they are created. This differs from assignment and reassignment. So let's say that we have zoo equals lion and tiger, and then you overwrite that value. So you cross it off, you delete it, and you do zoo equals elephant, zebra, and kangaroo. So this is an example of reassignment. And we can do that with strings. We've seen reassignment before. Augmented assignment is an example of reassignment that we use all the time. So what if you want to change a specific element or elements inside the list? This is able to be done using the index assignment or the slice assignment. Now, we've been able to index and slice on strings, but we've never been able to go in and actually change just one character in the string. You just had to rewrite the whole string. So what we're saying here is we can go in and we can change a piece of the list. And that's what's really special about assignment. List mutation with index assignment. So unlike strings, lists can be mutated after they are created. They can be changed. You can use an index assignment to mutate the list such that the value of an element of a list as the indicated index is changed. So we have list of index equals new element. So here we have a list of cities. And we go cities of 1 equals Fort Lauderdale. So in the original list, the 1th item is Tampa. And what we're saying is overwrite just the item number 1, replace it with Fort Lauderdale. And so when we ask Python to report back the cities, we see that Tampa has been swapped out for Fort Lauderdale. You can also do slice assignment. A slice can be cut out and replaced by new entries using the slice operator. The length of what is spliced out does not need to be the same length as that is what is spliced in. So you can do a list of, and then you have a start index, a colon, and a stop index equals the splice list. So the syntax of this is a little bit odd maybe at first, but let's just take this and break this down a little bit. So you're going to have the list and you're basically going to highlight the thing that you want to delete. I like to think of it just like maybe you've done this in a Microsoft Word or a Google Doc where you use your cursor and you highlight something and then you press the delete and it deletes all the things that you highlighted. This is the same idea, but the highlighting is being done with the start index and up to but not including the stop index. So that's how you're selecting the thing. And in what you're doing is you're then pasting in the contents of whatever is in the splice list. Now, the reason why the type has to be list is because you could replace in multiple items and you couldn't, what else would you use to indicate multiple items? You need a list to hold the multiple things. So it doesn't actually put the list inside of it. It takes the elements of the list and expands them into the other list, but you lose the brackets. Let's take a look to see how this would work. Here we have a list called cities. Now we're going to make a selection of cities from 0 up to but not including 2. 0, 1, 2. So we'll select Key West and Fort Lauderdale. It's like these are highlighted. Now we press the delete, but the cursor is still there and we paste in the contents of whatever list was mentioned. All of these cities. So Miami, Daytona, Tallahassee, and Pensacola. No, there's a lot more than there was that we highlighted. Yeah, that's okay, that works. So the thing that was not highlighted and deleted was Clearwater, and all the things that were added in were all of these. So we look at the resulting new list. It contains all of the items from the new list and the leftover piece that didn't get deleted from the first one, that's Clearwater. And so that's how it works. We also have this concept of aliasing. Now, aliasing is something that we don't have in Python in the strings. Aliasing is something like this. In Chicago, there is a notorious gangster. This was back in the 1920s. He was a notorious gangster in Chicago. And you know, if you're a notorious gangster, you can't exactly go around using your name in public because, you know, you might have to go to jail. So this gangster, Al Capone, also went by a whole bunch of aliases so he wouldn't get caught. He went by Al, Scarface, and Albert Costello. In the dictionary, an alias is a false or assumed identity, a spy operating under the alias Farsad. Synonyms are assumed name, false name, pseudonym, sobriquet, or incognito. What is an alias in Python? An alias in Python is a variable that points to existing data, a second or more variable pointing to the same data. Here we have a variable 1 equals some value. Okay, no big deal. Variable 2 equals variable 1. Okay, well, I wonder what that means. Creating an alias. Cities equals Miami, Tampa, and Clearwater. Cities 2 equals whatever cities equals. That means that they both point to exactly the same data on the disk. So we now have two names for the self-same list. Aliasing has occurred. Now, the plot thickens when we need to talk about mutability. Aliasing occurs when two variables refer to the same list. Both variables point to the exact same list. Aliasing has occurred. We just saw an example of this. Each variable points to its own copy of the list. This would be a different case. Cities equals Miami, Tampa, and Clearwater, and cities 2 happens to have the same values in it. How many independent lists do we have here? There are 2 independent lists because each of them has their own contents. Whereas this is the same list, but 2 things are pointing to the same one. Here there is aliasing, here there is not. So the question then becomes, if we mutate something, what's going to happen? All right, so if it's the self-same list, whether you mutate it under one alias or the other alias, it's still the same list. So the effect of that is this very bizarre situation where you could not change a certain list name. So it appears that you haven't changed that list, but you changed the list under its alias. And then the other list, the other apparent list, also becomes changed. That's how this can get to be a little bit confusing and why you have to be very savvy about understanding about the aliasing. So let's take a list. Here it is, x equals 1, 2, 3, right? Y equals x, and z equals 1, 2, 3. Okay, these lists are the same. How many copies of the list exist? Is it 1? Well, it's probably not 1 because I see 2 copies there. All right, well, is it 2 or is it 3? Because you see that there are 3 variables, right? X, Y, and Z, they're all a list. You should draw the diagram to help convince yourself how many lists you have. What will the list X, Y, and Z be after the mutation? So we're going to go in and we're going to change list Y. Now the question is, which, if any, of the other lists get affected? Why don't you take a moment to consider that before you move on? And when you're ready, let's proceed to the next slide. We'll see you soon. All right, so let's see how you did. Aliasing and mutability. So remember, we had these three lists, X, Y, and Z. X equals 1, 2, 3, and Z also equals 1, 2, 3. They happen to be the same list in terms of the content, but the question is, are they in fact actually the same list? So the answer to that is no, they're not, because each of them has their own variable and they each have their own data. The oddball here is this Y, because Y equals X, and this right here is what clues us into aliasing is happening, and we're showing this with this diagram over here. X has a list and Z has a list. They just happen to have the same contents, and Y is equal to whatever X is equal to. So if we go in and we mutate the list, the Y list, the Y of 1, 0, 1, selects this 2 right here, equals 0. So we're going to do a reassignment here at this position. I think it's not too difficult to understand that the Y list would now have 0 in it. But notice this curious thing that the X list does too. Even though we didn't actually change the X list explicitly, it changed because they're both pointing to the same list, and we changed this list. That's why it has a mutation in it. And so this is the important thing about aliasing, because you can get that effect that X appears to not have been changed, but in fact, the data content of X is changed because it got changed through the alias Y. And Z is unaffected by it because Z is a completely different copy. So there has been no mutation in Z at all. All right, I think this is a good place to put on the pause. So thank you so much for joining us. I hope you have enjoyed learning about the lists and are appreciating these as a very useful data structure that you can use for your projects. And we look forward to continuing our discussion of the list in our next video. We'll see you soon. Bye-bye.